So anytime we're using D2L, we can use the LaTeX equation editor, and some people call that $ math. And this is geometry, so I'm going to do basically geometry stuff only, but the distance between points A and B is, and so I may have to come over here to get more stuff, right? This 3 dots opens up more menus, and here is, and you can enter them other ways if you like, but LaTeX is excellent. And here the distance between AB is just AB. You can see that it inserts it in line. It's a little above the line, but that'll be fine for right now. We can always center it below, a line of text. So that's how it works. That's the one we're going to use. Let's look at triangles. So here we go, LaTeX equation. And so with LaTeX, we use a backslash and the word triangle. And then I can type ABC. And what will happen when I insert that is that I'll get this nice triangle ABC. And like I said, we can center that if we'd like. And let's see what else we have. I'm going to keep it over here to the left. Oops, I guess I'm not. Okay, so we have triangles. We have angles, of course. If I can type. So angles, and it will just be backslash angle. Okay. Sometimes this would be a measured angle, and that's a slightly different notation, right? So and that's just backslash measured angle. Oh, and it thinks I've misspelled it, but it's still popping up in the preview as looking correct. So I'm going to hit insert. Yep, that's a measured angle. So we're doing pretty well. What about congruence? So, for example, I can type that angle ABC is cong, so backslash CONG is congruent to backslash angle XYZ. We also have similarity. For example, I could say that triangle ABC is similar to triangle XYZ. All right, so I have things are similar. Note that if I'm talking about angles, oops, sorry, I just wanted to click on that. If I'm talking about angles, they're equal to each other. If I'm talking about the measured angle, they're equal to each other. If I'm just talking about the angles, they would be congruent to each other. Measured angles are equal to each other. Just plain angles are congruent to each other. All right, so we have similarity. What else do we need to look at? Oh yes, there is a square. Most people just use this at the ends of proofs, but let me show it to you. So for example, I could do square ABCD. Right, but like I was saying, most people will use this just, if you look in the preview here, just as the square, the open square to put at the end of a proof instead of QED. So there you go, there's a square. Circle. So wait, I'm sorry, I was going to put a square here. Square. And what about a circle? It's exactly what you'd think. These get very easy to guess after a while, right? It's going to be backslash circ. And let's say circle AB, right? This will be a circle with center at A and B is on the circle, so the distance AB is the radius. So circle AB. Also, this is what we use for degrees. So for example, we can do measured angle in degrees um, and pop in something like, see, so measured angle ABC equals 90 degrees. And I'd like to put degrees in, so I'm going to use a caret for a superscript, and then I do \circ, right? So what I want is I want that circle and as a superscript, and then that will look pretty much like a degree symbol. That's what we use. Notice this looks better if you're typing a little more. Typing it in line looks a little better, but it does raise it above. The bottom of the equation is above the bottom of the line. Line segments are pretty easy. The segment AB is going to be overline, and if you don't put the curly brackets, do you see how the overline is only over the A in the preview? So what we do with overline is we put curly brackets before and after, and then that tells it to spread that overline over everything that's inside the curly brackets. In statistics, we often do overline X, right? X bar for the average, sample average. Uh, Here we're in geometry, so I'll go back to this one, overline AB. Now arrays and lines are a little tedious, but it's not too bad. So let's do array first. So unfortunately, we don't have something like \array. What we do is we have \over left arrow. And I put in the curly brackets and AB. Oops, I wanted over right arrow, sorry. Well, technically that is array. Sorry about that, but I will put the right arrow in. Over right arrow will give me array. And then a line where I want the symbol on top to be a line pointing both ways is the slightly wordy over left right arrow AB. Okay, so that's pretty much everything I can think of that you might need, so I will save this video and post it right in here so that you'll have a tutorial on the basic geometry and $ math that you'll need to insert into discussion posts or take. We will be taking the midterm in D2L. You will be proving things in the D2L quiz. There will be text areas where you'll be able to save things like this. So just be ready. You will need to use $ math or some kind of equation editor inside D2L, and you should be prepared for that. All right, get to work, try it out. It's not that hard.